Hello guys, how are you people? We are here back again with a very new session of our ongoing crash course, and today's topic is oscillation and SHM. Now what is SHM? SHM is simple harmonic motion. So this is a very beautiful chapter, very close to my heart because I seriously love teaching it, and there are so many things in it, and there are so many tricks also how we can actually find out the result of simple harmonic motion in a very crisp and a very time efficient manner. Okay, so हम इन सारी चीज़ों के बारे में डिस्कशन करेंगे और बहुत ही अमेजिंग सेशन होने वाला है. बट फॉर द नेक्स्ट 2 आवर्स आपके पास जितने भी काम हैं, वट एवर यू हैव बीन डूइंग, just keep it aside. For the next 2 hours your entire attention should be towards the screen. There are so many good questions in it, and पूरा बहुत अच्छा insight है about simple harmonic motion. Okay, if I talk about the application of simple harmonic motion, so just mind my words, wherever you encounter time period, calculate the time period. It's always either of a pendulum or the time period will be of an object which is in SHM. Okay, so time period के जितने maximum questions आते हैं ना, वो SHM से कहीं ना कहीं relate करते हैं. इसलिए वो magical equation which actually tells us that acceleration is directly proportional to minus x, जो कि condition भी होती है SHM की, वो समझना बहुत ज़रूरी हो जाता है कि how that equation is actually arising, and that particular condition, how it is very eminent whenever we are to justify or to tell whether any motion, any oscillatory motion is SHM. So बहुत ही proper तरीके में एकदम streamline की तरह हम लोग स्टेप बाय स्टेप पहले पीरियोडिक, ऑसिलेशन, देन उसके बाद SHM, क्या सारी चीज़ें हैं, फिर SHM में भी एंगुलर SHM क्या होता है, उन सब के बारे में बात करेंगे. देन फिर कुछ केसेस भी देखेंगे जहाँ पे स्प्रिंग मास सिस्टम है, एंड उसके बाद फाइनली हम फोर्स्ड और डैम्प्ड ऑसिलेशन से ये लेक्चर फिनिश कर देंगे. ठीक है, एंड वन मोर थिंग, आपके टेस्ट्स लाइव हो चुके हैं ऐप पे. सो आप ऐप पे जाइए अभी. जस्ट आई विल बी टेलिंग यू कैसे आप उस चीज़ को एक्सेस कर सकते हो और कौन से कोड्स आपको वहाँ यूज़ करने हैं जिससे आपके फ्री टेस्ट लाइव हो पाएंगे. ठीक है, इफ़ आई टॉक अबाउट माई सेल्फ, माई नेम इज़ आदर्श राय, एंड आई हैव बीन मेंटरिंग एंड ट्यूटरिंग स्टूडेंट्स फ्रॉम पास्ट 6 years to crack JEE NEET exam. Okay, and if I talk about Extramarks, so Extramarks has a very good record, and we have ensured that out of every 7 candidate, 1 student has been selected in JEE Main. Okay, so that's a very good record in itself, but we are still not satisfied, and this is the reason why we are offering so many things for you people, जिससे आप लोगों की ranks और ज़्यादा improve हो पाए. Okay, and if I talk about the content created on the application, which you'll find, the link of the app you can find in the description, उस पे content is truly, मतलब it's brilliant in itself. It's especially the most special feature about the content is according to the standards of present expectations of NTA, what NTA is expecting और what JEE Main exam is expecting from the students. So उनको दिन ध्यान में रखते हुए, पुराने बहुत सारों के पेपर एनालाइज करते हुए, मॉडिफिकेशन देखते हुए, कैसे पेपर्स मॉडिफाई हो रहे हैं, किस टॉपिक से ज़्यादा क्वेश्चंस आ रहे हैं, किस टाइप के क्वेश्चंस आ रहे हैं, उनके बेसिस पे वो क्वेश्चंस क्रिएट किए गए हैं जो कि आपको ऐप पे मिल जाएंगे. साथ ही साथ वो सारे क्वेश्चंस के आपको वीडियो सोल्यूशन, साथ ही साथ रिटन सोल्यूशंस भी मिल जाएंगे. सो यू डोंट हैव टू सर्च एनीवेयर, यू जस्ट हैव टू टेक अ स्निप, यू जस्ट हैव टू, देयर आर सो मेनी सर्च ऑप्शंस ओवर देयर जिनके थ्रू आप उन क्वेश्चंस को प्रैक्टिस कर सकते हो. Okay, so this is a very good opportunity, you should definitely go to the app, and मैं अभी आपको आपका इंटरफेस बताता हूँ. सो अब ये क्या है, ये आपके सारे कोड्स हैं. जैसे हमने रोटेशनल मोशन का सेकेंड लेक्चर कंप्लीट किया, राइट? आपने क्रैश कोर्स देखा होगा, एंड जिन स्टूडेंट्स ने नहीं देखा है क्रैश कोर्स, डू विजिट इट. आपको लिंक या डिस्क्रिप्शन में, आप जैसे ही JEE के चैनल पे जाओगे एक्स्ट्रा मार्क्स के, देन आपको क्रैश कोर्स में रोटेशनल मोशन टू ग्रेविटेशन, ये सारे ही क्रैश कोर्स मिल जाएंगे. यू जस्ट हैव टू वॉच देम, इनको देखो, एंड इनको देखने के बाद इनसे रिलेटेड टेस्ट सॉल्व करो. एंड टेस्ट आपको कहाँ मिल जाएंगे? सो टेस्ट आपको, you need to, yeah, one very important news, Extramarks has its official learning partner as Arsenal. So बहुत ही जल्द आपको बहुत amazing कंटेंट और बहुत अमेजिंग चीज़ें दिखने वाली हैं फुटबॉल से रिलेटेड, जहाँ पे फिजिक्स भी बहुत ज़्यादा डायल इन होगी। सो इस चैनल को जिन्होंने सब्सक्राइब नहीं किया है वो जल्दी सब्सक्राइब कर लें, क्योंकि बहुत अमेजिंग कंटेंट आपको जल्द ही मिलने वाला है। एंड अगर मैं ऐप की यूआई की बात करूँ, डैशबोर्ड की बात करूँ, सो आपका जो इंटरफेस होगा वो कुछ इस टाइप का होगा, जहाँ पे आपको पहले रजिस्टर करना है। एंड ऑब्वियसली आप क्लास 12 प्लस में हैं, सो क्लास 12 प्लस के रजिस्ट्रेशन से जाना, आप वहाँ पे सारी डिटेल्स जैसे आप फिल करोगे देन वहाँ पे आपको ये आइकन्स मिलेंगे, राइट। आप में आपको ये आइकन्स हंट करने हैं। आइकन्स हंट करने के बाद ओपन टेस्ट में जाना है, ठीक है। आप जैसे ही ओपन टेस्ट में जाओगे, दिस टाइप ऑफ अ विंडो विल ओपन इन फ्रंट ऑफ यू, जहाँ पे ये जो टेस्ट आईडी आप देख रहे हो ना, इस टेस्ट आईडी में ये कूपन्स डालने हैं। ये जो कूपन्स आपको मैंने अभी जस्ट दिखाए, ये कूपन्स, ये सारे कूपन्स आपको एक कोड याद कर लो, इसे कॉपी करो और वहाँ पे पेस्ट करो। जैसे ही वहाँ पे आप पेस्ट करोगे आपके लिए टेस्ट ओपन हो जाएगा। एंड टेस्ट ओपन होते ही इट्स अ टाइम ड्यूरेशन टेस्ट, जिसमें आपको एक लिमिटेड टाइम फ्रेम में आपको क्वेश्चन सॉल्व करने हैं। एंड द बेस्ट पार्ट, the most lovable part of this test is the analysis of this test. So can you see just how comprehensive the analysis is? It gives you that scorecard, it gives you a percentile, then your peer analysis, then your efficiency, very very important. Students just do on questions, they never focus on their efficiency, whether it is improving or not, because in those 3 hours, in those tense situation, you have to perform, right? So it great amount of result, और what should I say, बहुत ज़्यादा रिजल्ट आपकी एफिशिएंसी पे डिपेंड करता है कि आप वहाँ कितना अच्छा परफॉर्म करोगे, आपकी परफॉर्मेंस डिपेंड करती है। सो एफिशिएंसी आपको बताएगी टाइम के हिसाब से। देन पीयर एनालिसिस में आपको ये पता चलेगा कितने क्वेश्चंस आपने गलत किए हैं, बाकी लोगों ने कितने गलत सही किए हैं। डिफिकल्टी वाइज क्वेश्चन एनालिसिस है। आइडेंटिफाई योर स्ट्रॉन्ग एंड वीक एरियाज, मतलब स्टूडेंट्स हंट फॉर पीपल हु कैन जस्ट टेल देम कि what is my strong and weak area, because nobody amongst us also, even I know a bit about my strong and weak areas, but truly completely I can never imagine I will ever know. So I just keep on doing work, वो हमारा कर्तव्य है, हमें काम करते रहना है। स्ट्रॉन्ग एंड वीक एरियाज हमें पता चलते जाएंगे। सो वो स्ट्रॉन्ग एंड वीक एरियाज आपको यहाँ पे पता चल जाएंगे। इवन ये भी पता चलेगा आपको किस सेक्शन में इंप्रूव करने की ज़रूरत है। सो इतनी कॉम्प्रिहेंसिव एनालिसिस रिपोर्ट अगर मुझे मिली होती जब मैं प्रिपेयर कर रहा था, आई ऑल्सो हैव गिवन द एग्ज़ाम, तो आई थिंक मेरी और अच्छी रैंक होती, मेरा और अच्छा स्कोर होता। Okay, so this is a very very good thing which is being offered to you by Extramarks, and you should definitely avail this benefit. Hi Ankush, how are you? Hi Raktim, how are you? Good evening Raktim, and Devendra, very good evening to you. आप सेशन देखो, सेशन अगर आपको अच्छा लगे यार लाइक करो, अपने सारे दोस्तों को बताओ, क्योंकि हम सेशन बहुत ही अमेजिंगली चल रहे हैं हमारे सेशन, हमारा सब्सक्राइबर बेस भी बढ़ गया है। एंड lot of thanks to you from the entire Extramarks family. You have been very supportive and we still need your support. हम what we want is, हम रिवोल्यूशनाइज करना चाह रहे हैं एजुकेशन को, जिससे हर एक स्टूडेंट तक ये क्वालिटी लेक्चर्स पहुंच पाएँ। सो काइंडली सब्सक्राइब करिए एंड शेयर करिए सेशंस को, बिकॉज देयर मे बी समवन जिनको नीड होगी ऐसे लेक्चर्स में, जो कि इधर उधर बहुत सारे चैनल्स और बहुत सारे लेक्चर्स को देख रहे होंगे, बट एक क्लियर विजन, एक क्लियर माइंडसेट और प्रॉपर स्ट्रैटेजी के साथ उनकी प्रिपरेशन नहीं चल रही। एंड जब आप ऐसे इधर उधर बहुत सारी चीज़ों में इन्वॉल्व रहते हो, देन ऑब्वियसली फोकस डिस्टर्ब हो जाता है एंड द एग्जाम डिमांड्स फोकस फ्रॉम यू पीपल। सो इट इज़ वेरी वेरी इंपॉर्टेंट आप एक परफेक्ट, एक प्लान्ड मैनर में ही प्रिपरेशन करो। बहुत ही जल्द डेट्स लाइव हो जाएंगी, कब से आपके जेई मेन होने वाले हैं तब काउंटडाउन स्टार्ट हो जाएगी। अभी आपके पास फ्री टाइम है, यूटिलाइज दिस टाइम। जितने ज़्यादा क्वेश्चंस प्रैक्टिस करोगे, जितने ज़्यादा अच्छी तरीके से सेशंस देखोगे, अपने कॉन्सेप्ट्स रिवाइज करोगे, टेस्ट सीरीज दोगे, बहुत ही जल्द टेस्ट सीरीज भी लाइव हो जाएंगी ऐप पे। सो आप ऐप डाउनलोड करो जिन लोगों ने नहीं की है, और क्वेश्चंस के मजे लो, टेस्ट भी दो। एंड इन्हीं सब चीज़ों के साथ फिर चलो हम स्टार्ट करते हैं आज का सेशन। एंड विदाउट टॉकिंग अबाउट पीरियोडिक मोशन, आई कैन नॉट एवर एक्सप्लेन व्हाट अ सिंपल हार्मोनिक मोशन इज। सो व्हाट डू आई मीन बाय पीरियोडिक मोशन? फर्स्ट ऑफ ऑल, so periodic motion, by the name itself, it gives you an idea that any motion which repeats itself after a particular interval of time is obviously what a periodic motion is, and that's completely true. That's completely true. So I'll just tell you how to relate periodic motion with oscillatory, vibratory, and then finally with SHM. So periodic motion is any such motion which is repeating itself after a particular interval of time. So you must have heard of Halley's comet, 78 years में जो दिखता है. Then उसके बाद Earth का revolution around sun, it's a periodic motion. Then pendulum का motion is a periodic motion. So there are so many examples of periodic motion, right? And all in all, अगर mathematical representation बोलूँ, so अगर कोई मान लो function है, अगर कोई function है जो कि represented है, उसका जो path है वो represented है in terms of time, क्योंकि अलग-अलग time पे उसके path की position अलग-अलग होगी, तो उसकी जो position है that is depending upon time. Say suppose उसकी जो position है r, that is a function of time. So ये जो पोजीशन है ना, कुछ कैपिटल टी टाइम के बाद वापस वही हो जाएगी. एंड दिस इज व्हाट दिस रिलेशन इज. ये आपकी एक इनिशियल पोजीशन है, ये आपकी फाइनल पोजीशन है, और पीरियोडिक मोशन वो है जिसकी फाइनल और इनिशियल पोजीशन सेम है. कितने टाइम के बाद? एक कैपिटल टी टाइम के बाद. और ये कैपिटल टी टाइम क्या कहलाता है? टाइम पीरियड कहलाता है. टाइम पीरियड कहलाता है टी. सो पीरियोडिक मोशन के रिपीट होने का जो टाइम पीरियड होता है उसे कैपिटल टी से डिनोट करते हैं. अब आगे बात करते हैं ऑसिलेटरी मोशन की. सो ऑसिलेटरी मोशन एक ऐसा पीरियोडिक मोशन होता है जिसमें रिपीटेशन तो होता है, क्योंकि वो पीरियोडिक तो है ऑब्वियसली. एक टाइम के बाद, एक पर्टिकुलर टाइम के बाद पोजीशन वापस सेम आएगी. बट यहाँ पे एक स्ट्रिक्ट फीचर होता है ऑसिलेटरी मोशन के साथ, टू एंड फ्रो का. टू एंड फ्रो का दैट मीन्स एक फिक्स पॉइंट के अबाउट लेफ्ट राइट लेफ्ट राइट लेफ्ट राइट मोशन होगा. जैसे कि इस केस में आप देख सकते हो, तो यहाँ पे आप एक फिक्स पॉइंट देख रहे हो जहाँ से मोशन स्टार्ट हुआ. इसके अबाउट अगर लेफ्ट राइट टू एंड फ्रो मोशन होगा तो ये ऑसिलेटरी मोशन कहलाता है. ठीक है, इस मोशन को क्या बोलते हैं हम? ऑसिलेटरी मोशन बोलते हैं. अब ऑसिलेटरी मोशन की भी कोई डेफिनेशन होगी सर? डेफिनेटली होगी. डेफिनेटली ऑसिलेटरी मोशन की एक डेफिनेशन होती है. और ऑसिलेटरी मोशन में क्या होता है कि जैसे देखो, सपोज आपका जो ऑब्जेक्ट है वो यहाँ पे, राइट, यहाँ पे, अब वो यहाँ पे है और उसकी वेलोसिटी ऑब्वियसली आगे की तरफ है. तो अगर इस ऑब्जेक्ट की वेलोसिटी आगे की तरफ है और जस्ट इमेजिन इस ऑब्जेक्ट पे फोर्स भी आगे की तरफ लगेगा, तो कैन यू एवर थिंक कि ऑब्जेक्ट थोड़ी दूरी के बाद फिर वापस आएगा? नो, इट इज नॉट एट ऑल पॉसिबल. ये केस तब पॉसिबल है जब इसकी वेलोसिटी आगे की तरफ हो तो इस पे एक्सेलरेशन पीछे की तरफ हो. ट्रू. और जब वो ऑब्जेक्ट यहाँ है और उसकी वेलोसिटी इधर है तो उसमें फोर्स towards the mean position. मतलब all in all what I want to summarize is जो force लगना चाहिए that should be always directed towards that fixed point known as the mean position. And उस force की भी एक relation होती है, और relation किससे होती है? Displacement from its mean position से. कैसे relation होती है कि जो force लगेगा ना, ये जो F है, ये जो आप F देख रहे हो, किसी भी एक simple harmonic motion पे अगर आप एक सपोज यहाँ पे ऑब्जेक्ट है, ठीक है, और इस जगह मैंने ओरिजिन एस्टैब्लिश कर दिया, यहाँ पे मैंने क्या कर दिया? ओरिजिन एस्टैब्लिश कर दिया, तो इस पोजीशन को मैं पॉजिटिव एक्स से डिनोट कर सकता हूँ. डेफिनेटली कर सकता हूँ ना. राइट की तरफ है, इस तरफ है, यहाँ पे पॉजिटिव एक्स होता है और इस तरफ नेगेटिव एक्स होता है. तो पॉजिटिव एक्स से मैंने इसकी डिस्प्लेसमेंट डिनोट कर दी, और यहाँ पे उस पर फोर्स कहाँ लगना चाहिए? टुवर्ड्स द मेन पोजीशन. तो फोर्स लगेगा इधर, यानी नेगेटिव एक्स डायरेक्शन की तरफ. अगर मैं ऑब्जेक्ट को यहाँ पोजीशन करूँ तो यहाँ पे एक्स क्या हो रहा है? यहाँ पे एक्स आपका नेगेटिव है, लेकिन यहाँ पे फोर्स का डायरेक्शन क्या है? वो बॉस पॉजिटिव डायरेक्शन के अलॉन्ग है, राइट. सो आप इतना तो समझ गए होंगे, फोर्स और एक्स के बीच में एक नेगेटिव साइन का इन्वॉल्वमेंट है. एंड यही इक्वेशन होती है एक एक ऑसिलेटरी मोशन की, कि फोर्स शुड बी डायरेक्टली प्रोपोर्शनल टू माइनस ऑफ एक्स टू द पावर एन, जहाँ पे एन इवन मत ले लेना, क्योंकि इवन ले लोगे तो नेगेटिव साइन चला जाएगा, और नेगेटिव साइन चला जाएगा तो ऑब्जेक्ट के पास पीछे की तरफ फोर्स नहीं आएगा. एंड बिकॉज ऑफ दैट ऑब्जेक्ट कैन नेवर रिट्रेस इट्स पाथ बैक. मतलब वो एक पॉइंट के बाद रुक के वापस नहीं आएगा. दैट विल ओनली अकर जब उसका फोर्स इज ऑलवेज डायरेक्टेड टुवर्ड्स मीन पोजीशन. तो यहाँ पे n की वैल्यू बस ऑड होगी, ठीक है, यहाँ n की वैल्यू बस ऑड होगी, तो क्या क्या हो सकती है? n की वैल्यू 1 हो सकती है, ट्रू. n की वैल्यू 2 हो सकती है, बिल्कुल भी नहीं. n की वैल्यू क्या 3 हो सकती है? हाँ सर बिल्कुल. n की वैल्यू 5 हो सकती है? यस बिल्कुल. n की वैल्यू 7 हो सकती है? हाँ श्योर, बिल्कुल हो सकती है. अब इसमें सबसे सिंपल केस कौन सा होगा? सबसे सिंपल वाला बताओ. सबसे सिंपल इसमें केस होगा जब n की वैल्यू मैंने 1 ले ली. अब अगर मैंने n की वैल्यू 1 ले ली तो f इज डायरेक्टली प्रोपोर्शनल टू माइनस एक्स. तो सबसे सिंपल केस है ना, और यहीं से केस आ जाता है सिंपल हार्मोनिक मोशन का, कि सिंपल हार्मोनिक मोशन वो होता है जहां पे फोर्स x के डायरेक्टली प्रोपोर्शनल हो और उसकी x की डिग्री 1 हो. ठीक है. सो ये यहाँ पे केस आ जाता है आपका सिंपल हार्मोनिक मोशन का, जब आपने उस n को सबसे सिंपल ले लिया. सबसे सिंपल क्या है? दैट n इज इक्वल टू 1. Okay, so here comes your simple harmonic motion, and the only condition for any motion, any oscillatory motion to be considered a simple harmonic motion is that the force acting on it should be directly proportional to minus of x. And instead what I can say is, if force is directly proportional to minus of x, then acceleration should be directly proportional to minus of x, and this is the only condition of a simple harmonic motion, and this is the condition which you should remember, for the rest of your life wherever you get any case of oscillation. Because trust me guys, maximum times in your 11th, 12th and even in your engineering, you'll get the cases of simple harmonic motion only, because the cases much beyond than that are very complex to solve, and if they want you all to just solve a very simpler one, then you should always remember this equation, because maximum cases what you will encounter will be of simple harmonic motion only. So the usage of simple harmonic motion is in electrostats, yes it is in gravitation, yes it is in mechanics also, and there are so many incidents, magnetism में भी आ जाएगा ये involvement लेके, जहाँ torque लगेगा, angular SHM होने लग जाएगा. So बहुत ज़्यादा usage है, जहाँ भी आप oscillation time period की बात देखोगे, आपको ये question याद रखनी पड़ेगी और वहाँ पे वापस पुट करनी पड़ेगी, और यहाँ से क्या करना पड़ेगा, एक्सेलरेशन को x के डायरेक्टली प्रोपोर्शनल इक्वल प्रूफ करना है, और वहाँ से आपको ओमेगा स्क्वायर की वैल्यू निकल जाएगी, ओमेगा निकल गया तो टाइम पीरियड तो यूँ निकल जाएगा, बिकॉज ओमेगा इज 2 पाई अपॉन टी. ओके, सो आई सपोज यू ऑल हैव अंडरस्टूड दिस आइडिया ऑफ simple harmonic motion. What it is, it should, that acceleration should be directly proportional to minus x. There is one more kind of motion known as vibratory motion. So vibratory motion is just like oscillatory motion. In oscillatory motion what happens is the amplitude is very large, but in vibratory motion the amplitude is obviously very less. Say for example you all have a mobile, right, and mobile is on vibration mode. So whenever a mobile is vibrating, nobody says that it is oscillating. The reason is because the amplitude is very small, and whenever a simple pendulum, I take the case of a simple pendulum, so it oscillates, it never vibrates. And suppose if the simple pendulum also has a very small amplitude, then obviously we will say it is vibrating. So if the amplitude is very small, then the motion, the oscillatory motion is termed as vibratory, and if the amplitude is very large, then the motion is termed as oscillatory. And this is what the entire expression of vibratory and oscillatory motion is. Okay, Saji, I am very good. What about you? And very hi to you. Abhishek, good evening. Very good evening Abhishek, how are you? So इसी के साथ हम सेशन आगे बढ़ाते हैं. सिंपल हार्मोनिक मोशन में पता चल गया है. सो अब सिंपल हार्मोनिक मोशन की कुछ की पॉइंटर्स हैं जो कि हमें पता होने चाहिए, जैसे कि व्हाट आई सेड इज force should be directly proportional to minus x, so f is equal to minus of omega square x, f is equal to minus kx. ये रिलेशन है जहाँ पे हमने एक स्प्रिंग कांस्टेंट का केस लेके बताया, आपको चीज़ें रिलेट करने की कोशिश की है कि एक मास m है और इसको हमने डिस्प्लेस कर दिया है, तो k यहाँ पे स्प्रिंग कांस्टेंट है और ये कि x के बराबर हो जाएगा, मतलब इस पे जो फोर्स लगेगा दैट विल बी इक्वल टू इक्वल्स टू माइनस के एक्स. एंड इन दोनों से रिलेशन हम क्या निकाल सकते हैं कि m इंटू ओमेगा स्क्वायर एक्स विल बी इक्वल टू माइनस ऑफ के एक्स, या फिर m इज इक्वल टू माइनस ऑफ के एक्स, एंड यहाँ से रिलेशन फिर इस तरीके से आ जाएगी. सो एक सिंपल सा केस लेके हमने एक इक्वेशन, जनरल इक्वेशन ऑफ अ सिंपल हार्मोनिक मोशन इन टर्म्स ऑफ टाइम डिराइव करने की कोशिश की है. ठीक है, सो यहाँ f की जगह m इंटू ए रखा, डी स्क्वायर एक्स अपॉन डी टी स्क्वायर इक्वल टू माइनस के एक्स है. इस इक्वेशन को जब हम सॉल्व करेंगे इंटीग्रेशन यूज करके, तो हमारा x जो है दैट विल टर्न आउट टू बी x इज इक्वल टू a साइन ओमेगा टी प्लस 5. ठीक है, एंड दिस इज a general equation of a simple harmonic motion of any particle executing a simple harmonic motion in terms of time. ठीक है, एंड अगर मुझे x का रिलेशन पता चल चुका है तो आगे मैं वेलोसिटी और एक्सेलरेशन का भी रिलेशन निकालूंगा, बट उससे पहले क्वेश्चन कर लेते हैं. और ये क्वेश्चन क्या है, ये क्वेश्चन रखने का भी मेन पॉइंट ये है जस्ट टू डिफरेंशिएट अमंगस्ट यू व्हाट अ पीरियोडिक एंड नॉन पीरियोडिक फंक्शंस आर, एंड एक्चुअली हाउ टू कैलकुलेट द वैल्यू ऑफ टाइम पीरियड for any given periodic function. Okay, so mind my terms, whenever you get sine and cos functions, so they are always periodic, and whenever the discussion is about e to the power minus omega t and log of omega t, then obviously it is a non-periodic function. Okay, so these two are obviously non-periodic, and the periodic functions are a and b only. So let's discuss about them and calculate the value of time period. So a normal approach is, let's say suppose you are given with a function of x is equal to sine of omega t. So what will be the time period of this? So there is a very simple trick to it. What you just need to do, the time period of this will be 2 pi upon coefficient of t, coefficient of this small t. And what is the coefficient of small t? Omega. True, sir. So if this sin omega t turns out to be sine of 2 omega t, then over here in place of omega, the answer will be 2 pi upon 2 omega. If it is suppose omega by 2, then over here we have to place omega by 2. So whatever is the coefficient of small t, you just have to place it over here, and what you will be getting? You will be getting the value of capital T. That is the time period of this periodic function, because sinusoidal functions are periodic. If you remember the curves are like this, right? So they are periodic, right? They are periodic. They repeat their position after a particular interval of time. As in this case, the repetition is after this point, after a transition of angle of 2 pi. And if someone is thinking that, oh sir, over here also the periodic motion should repeat, so the value should be pi, this is wrong, because over here it is moving in downward direction and over here it is moving in the positive direction, just like the case initially. So this is a concern of mathematics now, but we should very well know that sinusoidal functions are periodic, and the calculation of the time period is obviously 2 pi upon coefficient of t, that is whatever is the coefficient of t written over here. Okay sir, ठीक है, done. I just got your point that ऐसे लिखा रहेगा तो भी निकाल लेंगे, ठीक है. But what about this? यहाँ पे तो addition of two sinusoidal functions दिया हुआ है, यानी two functions cut sinusoidal हैं जो कि और उनका time period दिया है. So in this case, how to proceed? You just need to take the LCM of that. Simple. You just need to take the LCM of that. So इसका time period कितना आ जाएगा? If I talk about this, तो इसका time period आ जाएगा 2 pi upon omega, and इसके time period की बात करूँगा तो वो भी आ जाएगा 2 pi upon omega. Now what will be the LCM of that? So इन दोनों का जो LCM हो जाएगा कितना होगा? Take the LCM of both these terms. इन दोनों का जो LCM होगा, that will instead be equal to 2 pi upon omega, and this is your final result. ठीक है, समझ में आया? बड़ी easily हमने कितनी clearly बता दिया कि जो LCM होगा इन दोनों का, that will be the time period of this entire function. और इसी को use करके क्या मैं इसका निकाल सकता हूँ? Yes, definitely, इसका भी निकाल सकते हैं. So इसका time period कितना हो जाएगा? 2 pi upon omega. And if I talk about the time period of this function, it will be 2 pi upon 2 omega. And if I talk about the time period of this function, it will be 2 pi upon 4 omega. Now how to proceed? How to proceed over here? So what you can do over here is, इस function को k ले लो. इस function को क्या ले लो? k ले लो. तो इस function को सर मैंने ले लिया k. तो ये कितना हो जाएगा in terms of k? What will the value of this in terms of k? Okay, sir, यहाँ 2 pi upon 4 omega. If I just multiply 2 and 2 as denominator and numerator, then this will be 2 pi upon 4k, that is our k. So this will be equivalent to 2k. And that's very true. That's very true. Now, if I talk about this value, so यहाँ पे how to generate k? What you need to do, you just need to multiply 4 and 4 in numerator and denominator. So 2 pi upon 4 omega will instead be k, and this will be written as 4k. Now what is the LCM of 4k, 2k and k? Can you do that? That's pretty easy, right? 4, 2 and 1. The LCM is obviously 4. The LCM is 4. So the final answer is, the LCM of all these terms is turning out to be 4k. And what is 4k? It is 4 into, what was k? It was 2 pi upon 4 omega. 4 gets cancelled. So the time period of the three functions combinedly written in front of you is 2 pi upon omega, and I suppose you all understood the result very clearly. It was done in a very clear fashion. तो मैं I just expect कि आप लोगों को समझ में आ गया होगा. And this is the approach which we use in solving these questions of time period. Now let's talk about these two functions. So what can you say about whether they are periodic or not? They are obviously not periodic. They are obviously not periodic. The graphs of them, you can observe the graphs of them even, it is not at all periodic. Okay, so these two functions are non-periodic. And these were the standard, some standard cases which you should know before proceeding further with simple harmonic motion. So as we have discussed it over here, so these two functions are periodic. Now let's talk about this question as well. So show that the displacement equation x is equal to 5 plus 4 cos omega t can represent a simple harmonic motion. Represent the mean and extreme positions of the oscillator on x axis. Okay, not an issue. If you just remember, we just had a word about a standard equation of a simple harmonic motion, that is x is equal to a sin omega t minus phi or plus phi, wherein phi is the initial phase, which is the initial phase. So this phi can be equal to 0. This phi can be equal to 0. This initial phase actually just tells us what is your point of transition, or what is your point from where you began. So suppose I began from the mean position itself, and this equation completely justifies that fact, that at t equals to 0 my position was 0. So obviously I began from mean position, and in this case phi will be equal to 0, and how I derived that result you will be just knowing in a while. How I can say that if this equation will be equal to x is equal to a sin omega t whenever I am starting from a mean position, okay, because at t equals to 0 the sine of omega t will turn out to be sine of 0, sine 0 is 0, that means x is equals to 0 and mean position has x equals to 0, right. So a general equation of this curve of, so not of a curve, a general equation of a simple harmonic motion can be considered as x is equal to a sin omega t, right. There is no phi. Now can you just alter this equation by a term as x is equal to 0, x is equal to 0, and why I am doing that is because it actually gives me an idea that this SHM is being performed about origin. That means if this is a number line and here we have plotted that 0, so this is the mean position, and the oscillation is obviously occurring in this direction, okay. In such a manner the oscillation is occurring. So what can you say about this equation? So if you closely look towards this equation, this 5 can come over here and this equation will turn out to be x minus 5 is equal to 4 cos omega t, and since here it's sine, here it's cos, so obviously the SHM began from the extreme position, okay, it began from the extreme position, or you can alternately just replace it up as well. So what this actually means is that at t equals to 0, at t is equal to 0, where should be the position of this term? At t equals to 0 it will be equal to 4. So what will be the value of x? It will be equal to, so see, at t is equal to 0, if whenever there is a cos term the SHM begins from extreme position, and whenever there is a sine term it begins from the mean position. So let us say suppose at t is equal to 0 this entire cos 0 will turn out to be 1, so x minus 5 will be equal to 4 and x will be equivalent to 9. So x is equal to 9 when I am at t equals to 0, that is the mean position. So what is the value of mean position then? So extreme position I have determined, it will turn out to be x is equal to 9. So all in all, I just want you all to understand is the term which is written over here, this 0, just consider it to be x minus x naught, where x naught is always the position of the mean position. I am again repeating myself. So what happens is, try arranging your equation in this fashion that on the left hand side all the x and whatever numerals have been there, and on the RHS it should always be like a sin omega t plus phi or a cos omega t plus phi, and then what you can finally deduce is that whatever term has been written over here is the position of your mean position, okay. So 5 in this case, x is equal to 5 will be equivalent to the position of your mean position, and our amplitude obviously will be equal to 4, and the time period will be obviously equal to 2 pi upon pi, okay. So I suppose you just understood the idea. What we just need to do is we just need to write down the expression in this fashion, whatever I am just writing over here, x minus x naught is equal to a sin omega t plus phi, okay, a sin omega t plus phi, and or a cos omega t plus phi, whatever it is, and then you can finally claim that your mean position or the oscillation is occurring about this point, x is equal to x naught, and this is what they were asking, represent the mean and the extreme positions on the oscillator on x axis. So I can now very well justify whatever is the position of mean position. So mean position will obviously be at x is equal to 5, over here it will be x is equal to 9, the positive extreme position, and over here x is equal to 1 will be the negative extreme position, and as usual the amplitudes will be equivalent to 4 because cos has a coefficient of 4, okay. So I suppose you just got the idea how we can represent a simple harmonic motion, and this is the entire strategy, entire flow of that, okay. Now let us move ahead and discuss about the velocity and acceleration of a particle in SHM. So we very well now have the clear picture about what is a standard equation of a simple harmonic motion. So the standard equation is obviously x is equal to a sin or cos omega t plus phi. Just remember this fact, whenever we are using a sin omega t, that means that we have started off from the mean position, because at t equals to 0 our x was equal to 0, and whenever I am starting my equation at x is equal to a cos omega t plus phi, then obviously I have started off from the extreme position. Note these variations. It's not a fact that you cannot, if you have started off from mean position or extreme position, then you cannot express that in terms of sign. You can definitely, this phi will have an effect. So phi will be equal to pi by 2 if you started off from that extreme position, and the equation will completely justify the fact, because omega t plus pi by 2 will in turn turn out to be cos of omega t only. Okay, so this phi will adjust it, not an issue with that. But a general equation is either a sin omega t plus phi or a cos omega t plus phi. Now if we have the general equation of position, so can we calculate the general equation of velocity? Yes, we just have to differentiate it with respect to time. So on differentiating it with respect to time, what I'll get is that velocity will turn out to be a omega cos of omega t plus phi, and on further differentiating it, we'll get the relation of acceleration also, and acceleration will turn out to be minus omega square sine of omega t plus phi. So what I want you all to look forward towards is that this a sin omega t plus phi, it was equivalent to x, right? A sin omega t plus phi, right? So this entire expression can be represented as a is equal to minus of omega square t, and just don't get confused with this t which is written in the bracket. It just says that acceleration is also a function of time, and displacement is also the position is also a function of time. So all in all, this equation suggests is that acceleration is turning out to be minus of omega square x, and this is that magical equation which satisfies any simple harmonic motion, that acceleration should be directly proportional to x, and there should be a minus sign over here, and this is that magical equation which justifies any simple harmonic motion. So wherever you achieve or wherever you get or has been asked about any simple harmonic motion, justify whether it is or not, or just calculate the time period. They are claiming that it is a simple harmonic motion and you need to calculate the time period. What you just need to do is just try arranging those physical quantities over there such that you achieve a value of acceleration in terms of x, and now whatever is the coefficient of x, that will be your omega square. So from that you can very well calculate the value of time, because time is 2 pi upon omega. That's not a big deal. Okay. If I can do one more thing as well, I can just relate this acceleration, that velocity and displacement, the position as well, and in doing so I'll get one or two very important relations. So one very important relation is this one, that is you can just remember like this also, v square is equal to omega square a square minus x square. Okay, so this is the result, and about acceleration, so it will be acceleration is equal to minus of omega square x, and I can also relate velocity and acceleration as well. So velocity and acceleration can be related. What you just need to do is just replace this, do the square on both the sides. So it will be omega to the power 4 square is equal to a square, and this x square, now the value will be a square upon omega to the power 4. Just replace it over here, and in doing so you will get the value of velocity and acceleration as well, and I am just writing it down clearly in front of you. So three equations which you will arrive is, first one is a is equal to minus of omega square x, the other one is v square is equal to omega square a square minus x square, and acceleration square will be equal to omega square a square omega square minus a square. Okay, sorry, a square omega square minus v square. Okay, so these are the three relations relating x, v and a, and based on three relations I can also deduce some facts. I can also draw a graph between them, which I'll be just showing you in a quick span of time. So आप इन relations को भी याद रखो, इन relations की भी ज़रूरत पड़ती है कि suppose उन्होंने mean position बोल दिया, भाई mean position पे acceleration क्या होगा. So x equals to 0 रख देना mean position पे. अगर आपको ये पता है x is equal to 0 होता है mean position पे और x is equal to plus minus a होता है आपका extreme position पे, तो उसके हिसाब से what you can do is you can individually calculate the value of velocity and acceleration at both mean and extreme positions, and this is quite good in itself कि अगर आपको mean position पे velocity और acceleration दोनों पता है, ठीक है. So using those analysis only ये सारी चीज़ें आ जाएंगी. mean position पे x equals to 0 रखोगे इस equation में, तो v की value plus minus a omega आएगी. That means या तो वो left की तरफ जा सकती है, right की तरफ जा सकती है, but जाएगी maximum velocity से. But mean position पे acceleration हमेशा 0 होता है. That means in a simple harmonic motion, what is the position of equilibrium? It is the mean position. In calculation of time, what we'll be looking forward for? We'll be looking for the equilibrium point, that is the point of mean position, because at that point A is obviously equal to 0. If I talk about extreme position, x is equal to plus minus a, v will be equal to 0, and acceleration will obviously be equal to plus minus omega square a. If I draw a graph of vx, av and ax, so this graph is also very important, because I have seen so many times the graph has been asked, and also remember these arrows, because these arrows tell you, so the graph cannot exist in anti-clockwise fashion. Over here also it cannot exist in anti-clockwise fashion. So what this says is, I'll just give you a glimpse of that. So v and x are related as v square is equal to omega square a square minus x square. Okay. So obviously the equation will be of an ellipse, but at this point when v was equal to a omega, so what is the point? The point is obviously of mean position. So from mean position the particle is going for plus a, and this is the fact only because whenever an object is moving, let's say suppose this is moving, so at if it is having a velocity equal to plus omega a, then obviously the next destination of it will be the extreme position, that is at x is equal to plus a, and if it is having plus omega a, then the next destination obviously will be that. It cannot ever be this negative a, right? It has a velocity over there, so it cannot move in that direction. I suppose you are getting it. So this graph should always be in clockwise fashion. Similarly over here also, and over here we don't need clockwise, because there is no cyclic graph created over here, because it's just a straight line curve. Omega square x, a is equal to minus of omega square x. Just the slope will be equal to minus of omega square, and this is all. Okay. So now let's see the time relation, the variation of x, acceleration and velocity as well with related to time. And if I just assume phi to be 0, then x is equal to a sin omega t plus phi, v is equal to v naught sin omega t plus pi by 2, and a is equal to a naught sin omega t plus pi. And why I have represented in terms of sin is because when doing a phasor diagram, I can very well clearly state that velocity is at a phase change of pi by 2. So v is pi by 2 ahead of x, and a is pi ahead of x, and based on that their individual graphs can be created. So let's say suppose this is a graph of x, okay, x versus t. So v versus t, v is obviously pi by 2 ahead. So just if whenever pi by 2 is written over here, the entire graph shifts in backward direction. So this thing you will be studying in mathematics, okay. So whenever we add a pi by 2 over here, then the graph shifts pi by 2 in backward direction. So shift this graph by pi by 2. So this point will arise over here. So this is the graph like this. And if we have pi written over here, then the entire graph shifts by pi length. So this point over here will now come at this point, and hence the curve of AT has been created like that. Okay. So this is a normal standard, normal graphical analysis which you all should be knowing, because it's obviously studied and conveyed in mathematics also, but you should have this clear picture. Whenever you add some things over here, the graph shifts towards left, and whenever you subtract things, the graph shifts towards right. So this thing should be pretty clear. Okay. Okay. Hi Edu, how are you? How have you been? Now let's solve this question. So this question will actually give us a very good insight how questions are asked and what is the approach to solve them. So a particle is executing SHM with time period t, starting from mean position, okay. Time taken by it to complete 5/8 oscillation is. So over here what I will be telling you is, I will be giving you a very clear picture that how questions of simple harmonic motion can be solved or can be related, the entire simple harmonic motion, how it can be related with the help of uniform circular motion, okay. So just bear your patience over here and just focus your attention towards the screen. So what happens is, let's say suppose an oscillator, a simple object, is obviously moving on x axis. This is the position of plus a, and this is the position of minus a, and this is the object, and alternately what I am saying is, there is an object performing uniform circular motion with its angular velocity equivalent to omega. So what I just mean to say is, the projection of this particle over here will actually give you the motion of an object, a simple harmonic motion of an object. So what do I mean by this is that this object is obviously moving in a circular fashion with uniform angular speed. So the projection of it, suppose you have a light over here, so the projection of this small particle will obviously, when it is at this point, the projection will be here. When it is at this point, the projection will be here only. When it is at this point, the projection will be here. When it is at this point, the projection will be here. When it is at this point, the projection will be here, and so on and so forth. So the projections of this particle on this x-axis, so the projections are obviously equal to the simple harmonic motion of a particle with amplitude A and time period equal to 2 pi upon omega. And I will just show you how. So let us say suppose there was a particle executing simple circular motion, uniform circular motion, right. So here is this x-axis, over here it started, and after t time it reached this point. So this entire angle will be equal to omega t. Yes sir, truly. So this angle, this length, this radius obviously equal to a, because I have considered this position to be plus a, right. So this will be equal to a, and this angle will be equal to pi by 2 minus omega t. True? Very true sir. So what will be this length? What will be this length? This length which you are seeing over here, this length. What will be the value of this length? It will be a cos of pi minus t. So that x, if I just mention it to be x, this x will be equal to a into cos of pi by 2 minus omega t. So what I am getting over here is x is equal to a sine of omega t. And this was the reason I was telling you that whenever you started off from a mean position, consider this as your standard equation. And suppose I started off from this position and I move an omega t angle over here. So this angle, I am again redrawing the diagram. So let us say suppose now I am moving from this point, and after t time I have moved an angle of omega t. So this is my position. Now what is the projection? The projection will obviously be at this point. This will be the value of x. So x, how much it will be? So x will be equal to obviously a cos of omega t. So it will be x is equal to a cos of omega t, and this is the reason I told you whenever you start off from extreme position, you consider this as your standard equation. So I think you just got the entire thing which I have been focusing on previously. Now how this projection case and how the similarity between a uniform circular motion and simple harmonic motion can help us deduce this result. Let me give you an example and let me show you how it will help us. So what happens is, let's say suppose the entire motion, the entire one oscillation starting from this point till this point till this point is obviously one circular motion. Yes sir, true. So if I just analyze this 5 by 8 times oscillation, so it will be how much path this object might have moved. So it might have moved this A, then A, then A, then A. Very true. So what will be 5 by 8 of that? So obviously this 5 by 8 can be broken down into 4 by 8 plus 1 by 8 of the total distance, that is A plus A plus A plus A, that is 4A. So how much it will be? This will be equal to half. So this obviously 5 by 8 oscillation is half of the oscillation has been done, and after that 1 by 8th of the oscillation is still to be done. Okay, so writing this 5 by 8 in such a fashion is just to give you a clear picture that in that 5 by 8 what I can finally deduce is that half of the oscillation has been done. The object started off from this point, it went to the extreme position, it again came back and it is over here, and after that 1 by 8 times more oscillation has been done. So what will be 1 by 8 times of 4A? It will be equal to A by 2, and that's true. So that means the particle started off from this point, it moved over here, it again came back, and again it traveled this distance, and this distance is what? It is A by 2. Okay, nice. Now if I represent this on the circle, then on the circle the particle might have moved this distance, then this distance, and then it has moved from this distance such that its projection is somewhere over here. That's right, that's absolutely right. So now how, sir, you are planning to calculate the time? Now let's see, this half cycle will obviously be equal to T by 2. That's not a big thing we are about to calculate. So this time will obviously be equivalent to T by 2, and we just need to calculate this extra time. So T by 2 is for sure movement from this point to this point. Now we just need to calculate the time taken in moving by this much angle. Okay, by this much angle, we just need to calculate that, and I can very well calculate that. So how will be the approach over here? So I just need to calculate this angle, and theta divided by omega. Angular velocity is obviously what? Omega, that is the angular frequency of the simple harmonic motion. So theta by omega will actually give me the value of whatever time period is required from this point till this point. So can I calculate this value of theta? Yes, I can. See, this angle is a by 2, this is a, so I can calculate this value of pi by 2 minus theta. So this a of a cos, let's say suppose this angle is alpha. So a cos alpha will be equal to a by 2, a cos alpha is equal to a by 2. So cos alpha will turn out to be 1 by 2 and alpha will turn out to be pi by 3, that is 60 degree. So if alpha is 60 degree, then theta will obviously be equal to pi by 6. So pi by 6 can be replaced over there? Yes, it can be. So what my result is turning out to be t by 2 plus pi by 6 omega, pi by 6 omega. Now what are the options? The options are given in t. So I need to replace t over here. So what will be the value of t? Just multiply 2 over here and 1 2 over here. So this 2 pi upon omega will be t. So it is t by 2 plus t by 12. Now what is the next step? Multiply 6, 6t plus t is equal to 7t by 12. So finally the answer is turning out to be 7t by 12. Are you getting this point? मुझे बताओ, are you able to understand this, how I reach this result? और समझ में आया तो यार give me a like button. और इस approach से using the projection of an object on a circular path, हमने पहले ये समझा कि how that projection will help us reduce a simple harmonic motion along x-axis, and उसको use करके देखो कितनी easily हमने answer निकाल दिया, ठीक है? So just the brain which has to work, and finally you'll get the final answer, and it is obviously 7t by 12, ठीक है? So those who haven't understand this result, थोड़ा सा रिवाइंड करो वीडियो को, दोबारा देखो, एक दो बार और देखना, यू विल गेट इट, एंड इट्स अ वेरी वेरी ब्यूटीफुल क्वेश्चन. बहुत बार पूछा जा चुका है एग्जाम में, नॉट एग्जैक्टली दिस बट इन अकॉर्डेंस टू दैट, कुछ इससे रिलेटेड, कुछ टाइम कैलकुलेशन के. सो क्वेश्चंस डू कम एंड यू शुड वेरी वेल नो हाउ टू सॉल्व देम. ओके, हाय देवभर्गी, हाउ आर यू? Okay, so now let's talk about energy in simple harmonic motion. What is energy in simple harmonic motion? So energy over here can be stored in two forms. One is kinetic energy and one is potential energy. And as it has been, when we were kids, from that time also we have been studying that energy is stored in only two forms, potential and kinetic energy, and the summation of that is known as total mechanical energy. And so is the result over here also. We have a kinetic energy in a simple harmonic motion, and we also have a potential energy. And the reason to potential energy is because there is a restoring force acting on a simple harmonic oscillator. So it always needs to come back, right? Just imagine the case of a spring. So spring makes the object come back to its original position, wherein no expansion and compression has occurred. But again, because of that compression, whenever the object rises to the mean position, it again pushes it back. So there is a transition between kinetic and potential energy. The energy transition occurs all throughout its motion, and this is the case for every simple harmonic oscillator. So obviously for any oscillator, energy quotient will be divided into two segments. One, there will always be a kinetic energy, and one, there always be a potential energy. Okay, so the kinetic energy, the expression obviously will be equal to half mv square, and you very well know the value of v. You very well know the value of v square, right? So v square is how much? It is equal to omega square a square minus x square. So I can just replace that v square over here. So that can tell me that at x is equal to 0, at x is equal to 0, I will have the maximum value of kinetic energy, that is at mean position, and at x is equal to plus minus a, that is at extreme position, I will have my kinetic energy equivalent to 0. And obviously it should be, because at those points the particle had to stop for a moment and then again come back. So obviously at extreme position kinetic energy is 0, and kinetic energy will be maximum at mean position. And just the converse of it, potential energy will be maximum at extreme position, and it will be minimum at mean position. And so is the result of potential energy. It is conveyed as half of k x square. X square you very well know can be represented as a sin omega t plus phi. So this x has been replaced over here. So based on that also, if you just use this relation also, you can very well say that at x is equal to 0, your potential energy will be minimum is equal to 0. So obviously see, potential energy, how k minimum is 0. Kinetic energy, the minimum value of kinetic energy is obviously 0. Kinetic energy, because it's related with velocity, right? So if there isn't any velocity, then obviously kinetic energy will be 0. The question should over here should be that how can you say potential energy is 0? So potential energy is obviously a relative term, right? Even kinetic energy is a relative term, and but we never delve into that. We never discuss about that portion. We always consider kinetic energy to be absolute, but it isn't. Okay, so but most of the times what occurs is that potential energy, it's not an absolute term. We always have to consider a baseline for potential energy, and in reference to that baseline we can actually express the potential energy of any point or any level or any plane. Okay. So over here the normal convention of solving is that at the mean position potential energy has been considered, obviously it is the minimum value, and that minimum value has been considered to be 0. Okay. But you might encounter cases which says that potential energy at mean position is not equal to 0. Then what will be the value of mean position at extreme position? So don't get panicked by that, because if it isn't 0, then obviously it is the minimum value, and what you just need to do is you just need to add this term, and what you will be getting is the value of potential energy at the extreme position. So if it isn't 0, suppose it is 10 joules, then add this value to it. So you will get the value of potential energy at extreme position. That's it, fine. But if it is 0, then obviously this will be the value of potential energy at extreme position. Now energy is always conserved. Let's say suppose the entire oscillation is occurring in vacuum, so no sound is being created, no losses due to frictional forces, no dissipative forces are into action, so no work done or no losses due to any work done. So obviously the energy will remain constant. The kinetic energy and potential energy, the summation of it will be constant all throughout the motion. So initially what was the value of kinetic energy and potential energy, finally also should be the same value of kinetic energy and potential energy, and this will be the case, and this is pretty true, and that's the reason I can say that total mechanical energy in a simple harmonic motion is always constant, and it is equal to a very great result, which is half m omega square a square, and you should very well remember this result. It should be memorized by you all, that the total energy quotient of any simple harmonic oscillator will obviously be equal to half of m omega square a square, where a is obviously amplitude, omega is angular frequency, and mass is obviously represented by m. And if I draw a graphical representation of all these things, so obviously kinetic energy, if which one is the kinetic energy? This one, this dotted dashed one. So kinetic energy was obviously equal to 0 at extreme position, but at these positions potential energy was maximum, and slowly it began to rise, and kinetic energy became maximum at mean position. Then it again fell, and finally it became equal to 0 at the other extreme position. But the addition of both these is a constant line. That means the total energy is conserved. One more very important thing is that kinetic energy becomes equivalent to potential energy at a point. And what is that point? It is equal to, over here it will be minus a by root 2, and over here it will be equal to plus a by root 2. So this is the point where kinetic energy and potential energy have same magnitude. Okay, they have the value of same magnitude. So and the positions are plus minus a by root 2. Okay, so I suppose you have just understood this result. Now what we will be doing is we will be taking a very small break, and I will be just going and drinking some water, just hydrating myself. Till that time आप लोग भी थोड़ा पानी पियो, just take a small break, and if you come early then try solving this question, and break के बाद इसका आंसर डिस्कस करेंगे. ठीक है, जब तक के लिए solve this question. Okay, so hi everybody. So we are here back again, and okay, so how many of you have just solved this question? Just tell me. यहाँ पे देखो क्वेश्चन ये है, a particle starts oscillating simple harmonically from its equilibrium position with time period t. The ratio of kinetic energy and potential energy of particle at t is equal to capital T by 12 is. So हमें रेशियो निकालना है पोटेंशियल एनर्जी और काइनेटिक एनर्जी का t इक्वल टू 12 पे, एंड बड़ी इजीली हम निकाल सकते हैं। हमने देखो अभी रिलेशन देखा था कि t इक्वल टू 12 पे, t बाई 12 पे जो x की वैल्यू हो वो कितनी हो जाएगी। तो जो भी x की वैल्यू होगी उस हिसाब से आप यहाँ रिलेशन रख के बहुत इजीली आंसर निकाल देते हो। देखो फटाफट करते हैं हम। सो एट t इज इक्वल टू कैपिटल 12 क्या हो जाएगा। सो यहाँ पे मैं इस चीज को 2 पाई अपॉन ओमेगा, वेट फॉर अ व्हाइल, ठीक है। सो ये आपका t हो गया। देखो ओमेगा t निकालते हैं, ठीक है। ओमेगा t की वैल्यू कितनी हो जाएगी, दिस वन, एंड कैपिटल t की जगह मैंने 2 पाई अपॉन ओमेगा रख दिया। सो मैं यहाँ से स्टार्ट किया हूँ, इक्विलिब्रियम पोजीशन से स्टार्ट हुआ है ना विद टाइम पीरियड t। सो इक्विलिब्रियम पोजीशन से स्टार्ट किया एंड t बाई t टाइम के बाद यहाँ पहुँच गया। तो दिस इज द वैल्यू ऑफ दैट ओमेगा t। क्लियर, परफेक्टली क्लियर। इस ओमेगा से एक ओमेगा कैंसिल, दिस पाई, दिस 2 6, so it will turn out to be pi by 6. So this angle which you are noticing over here is instead equal to pi by 6. So what will be the value of x over there? So this angle, since it's pi by 6, it will be equal to pi by 3, and this obviously will be equal to a cos pi by 3, that is a by 2, ठीक है। So x की वैल्यू यहाँ से जो आ जाएगी that will turn out to be a by 2। अब x की वैल्यू हमें पता चल चुकी है, so we know the value of x. Can we not find the value of potential energy and kinetic energy? We can very well do that. So kinetic energy is obviously half mv square, that can be represented as omega square a square minus x square, and we very well know the value of potential energy itself, so that is equal to half m omega square x square, ठीक है। k is what? k is m omega square. So half k x square की जगह m omega square x square ले लिया। half m omega square will get cancelled, and what will be the value of a square minus x? What is x? x is a by 2. So a square by 4, that means 3a square by 4. So ऊपर आ जाएगा 3a square by 4 divided by, यहाँ पे कितना आ जाएगा, a square by 4. The answer will turn out to be 3:1. So what is the option? The correct answer is 3:1, and option C is the right one. So I suppose all of you have got the idea किस तरीके से हमने इस क्वेश्चन को सॉल्व किया। We just had to know the relation of kinetic energy and potential energy, and उस हिसाब से we could have very well done that. आप इसमें एक alternate approach ये भी कर सकते थे कि you could have expressed kinetic energy and potential energy in terms of स्मॉल a साइन ओमेगा टी, उसके टर्म्स में, टाइम के टर्म्स में भी जो एक्सप्रेशन है उसको रख के भी, उसमें t की जगह t by 12 रख के भी यू कुड हैव फाइंड द आंसर, एंड वहाँ से भी आंसर 3:1 आएगा। सो डू ट्राई दिस, इससे करके देखो आप, ऐसे आता है, अदरवाइज वी नो हाउ टू डू इट। ओके, then the next question is, a particle is executing simple harmonic motion with a time period t. At time t equals to 0, it is at its position of equilibrium. The kinetic energy time graph of the particle will look like. So what happens at equilibrium position? At equilibrium position, the particle is having maximum velocity. So maximum velocity means which of the graph is correct? पार्टिकल मैक्सिमम वेलोसिटी रखता है, यानी काइनेटिक एनर्जी की मैक्सिमम वैल्यू होगी, बिल्कुल सही। सो दिस ग्राफ कैन नॉट अकर, दिस ग्राफ कैन नॉट अकर, इन दोनों में से कोई सा एक ग्राफ होगा। अब काइनेटिक एनर्जी का व्हाट इज द टाइम पीरियड ऑफ काइनेटिक एनर्जी? टाइम, काइनेटिक एनर्जी कितने टाइम के बाद रिपीट होती है? सो इफ यू जस्ट रिमेंबर दिस फैक्ट दैट एट मीन पोजिशन काइनेटिक एनर्जी इज मैक्सिमम, राइट, एंड एट एक्सट्रीम पोजिशन काइनेटिक एनर्जी इज मिनिमम. So this is t by 4, this is t by 4. So max minimum, then minimum से maximum. क्या वो वही position पे आ गई? Some will say no sir, क्योंकि now it is moving in this direction. Earlier it was moving in this direction. But kinetic energy is a scalar quantity, brothers. It is not at all related with whichever direction you're moving. Displacement, position is, acceleration is, velocity is. So over there we said that the oscillation was occurring after a time interval of 2 pi by t, 2 pi by omega. But over here what is occurring is, since it's a scalar quantity, so we are just concerned about the magnitude. So magnitude, when it is repeating after an interval of t by 2. Okay, so the value which you have got, should be repeated after a time interval of t by 2 only. So this is the correct expression. As you can see over here and again at over here, I have the same values of kinetic energy. So what's the right answer? It is obviously option D. So do use this approach, okay, because using this approach what you can finally tell is you used elimination of options over there, so A and B got eliminated, and between C and D chances are there that you can be finally able to find out the right answer what it is, okay. Now a particle of mass 4 kg moves along x axis. Potential energy U varies with respect to x as. So potential energy variance with x has been provided to us. We need to find what is the maximum speed of the particle is. So what will be the maximum speed of the particle? Maximum speed of the particle, that too they are not asking what the maximum speed of particle, they are asking at which position the particle will have maximum speed. That means maximum speed कहाँ होगी? जहाँ पे maximum kinetic energy होगी. तो maximum kinetic energy कहाँ होगी? जहाँ पे minimum potential energy होगी. So where will minimum potential energy arise? So over here, see, U has been expressed as 20 plus x minus 4 to the power whole square. Okay, not an issue. Now, if I take any value of x, say I am taking x is equal to 0 or plus 2, minus 2, 4, any value. Over here, it will be a square of that. So this negative quantity, if any negative quantity is also arising over here, then the square of it becomes a positive quantity. That means something or the other will be added in 20. Something or the other will be added in 20. 20 में कुछ ना कुछ add होगा. So अब जब 20 में कुछ ना कुछ add हो ही रहा है, so why not make that term which is adding up in 20 be 0? Because if it turns out to be 0, then there is no term left to be added with 20, and obviously our potential energy's minimum value will be equivalent to 20. So the only case which I can think of is make this term to be equal to 0. So 0 square is 0, that means x should be equal to 4. So it was a one-liner, actually a brain teaser type of a question where you just had to find that at x is equal to 4, your u's value will be the minimum, and obviously since u value is equal to minimum, so there I can say is that the kinetic energy will be maximum, and instead what I can say is that velocity will be maximum, okay. So this was the answer to this approach. Now let's move and have a transition towards angular SHM. So what cases we have been dealing till now was, and we'll be dealing questions based on linear SHM also in a quick span of time, wherein few springs will be involved, and I'll be telling you how to actually find the effective K, effective spring constant as well. So those things, those motions or those SHMs are known as linear SHM, wherein acceleration is varying with displacement with a minus sign. Now if I talk about simple pendulum, or if I talk about torsional pendulum, or if I talk about rigid bodies rotating, then there occurs a case of angular SHM as well. So in rotational motion we have very clearly seen right that motion can be divided into a linear motion and a translational motion, and a rotational motion, right? That when objects are moving in leftward or rightward direction or along a straight line, then they are obviously termed to be translational motion, and whenever there is a curvature in their path, then those motions begin to be termed as rotational motion. So SHM cannot be away from these things. SHM also has been categorized as linear SHM and angular SHM, and the very basic, the very first case of angular SHM is the study of simple pendulum. So how simple pendulum oscillates? So over here what happens is, because of the torque, because of the extra torque, so whenever it just moves over here, I'll just draw you a diagram. So what happens, mg is acting in this direction, t is obviously acting in this direction. So mg will have a component like this and this. So suppose this is theta, so this angle will be theta. So here it will be mg cos of theta, and over here it will be mg sin of theta. And this mg sin theta, this t will obviously balance this mg cos theta and instead provide a necessary centripetal force also, but this mg sin theta will create trouble and will instead create a torque, and torque is also in such a fashion like a restoring torque. So suppose this object wants to move over there, but this mg sin theta is applying a torque and pushing it in backward direction, and if you just notice the torque, so the torque obviously will be equal to mg sin of theta into whatever is the distance, that is L. And obviously since theta is occurring in this fashion in anti-clockwise direction, but this mg sin theta is having a tendency to provide a clockwise direction of torque. So we impart a minus sign to it, okay, and this torque can very well be written as I alpha, and this, since this theta, all these cases of simple harmonic motion in a simple pendulum is always considered when theta is very small. How small it should be? It should be near to lesser than 10 degrees, 4, 5, 6 degrees, okay, not more than that. So if alpha is, if theta is very small, then the sin theta can be termed as how much? It can be termed as nearly equal to theta. So the sin theta will be nearly equal to theta, and this mg can be written as mgl into theta. So I will come over here. So what you are finally getting is that your alpha is being represented as minus of omega square theta. So what, can you just relate it up? So in linear SHM, what was the condition? That alpha acceleration should be directly proportional to minus x, and when I talk about angular SHM, if I talk about angular SHM, then in angular SHM the condition turns out to be that alpha, that is the angular acceleration, should be directly proportional to minus of theta, okay, just the replacement of acceleration by angular acceleration and displacement by, or the position by theta, and this is occurring. So the time period will be, this will be related with what? Here alpha will be equal to minus of omega square theta, where omega is angular frequency. So omega square will turn out to be this. So time period will be 2 pi I upon mgl. If you replace I by ml square, what you will be finally getting is the expression written in front of you, that is the time period of a simple pendulum will be equal to 2 pi under root of L by G. Okay. So I suppose you have just understood the result, and this is how we are going to proceed and find the value of time period in cases of simple pendulum. Okay. Now if suppose the pendulum is located in a frame and that frame is accelerating, so it is not static. If it is static or moving with constant velocity, then there is only one acceleration due to gravity over there, but now the frame, since it is accelerating, so then what we have to do is we need to calculate a G effective. We need to calculate a G effective, and G effective will instead tell you how the motion of pendulum will occur and what will be the time period. So let's understand a case. Now let's suppose this frame is accelerating in upward direction. So we have a pendulum, it is obviously oscillating, but this frame is accelerating in upward direction. So instead what G effective will turn out to be, there will be a pseudo acceleration acting in downward direction on the simple pendulum in addition to its existing acceleration due to gravity, and hence the time period will turn out to be 2 pi under root of L by G upon A. Okay. Now suppose if the motion of the frame is in downward direction, then what will occur? A pseudo acceleration in upward direction will act, and this will instead reduce the already acceleration due to gravity, and the result will turn out to be G minus A. Now suppose if G equals to A, then what will happen? No motion will occur. The time period will turn out to be infinity. As you can see, G minus A will be equal to 0, time period will be infinity. So the motion will not occur. There won't be any oscillations which you will see. Okay. And now let's just suppose the acceleration is on horizontal direction. So the frame is now moving in forward direction. So what will happen? There will be a pseudo acceleration on the object, on the bob, on the pendulum, and now the result will be the net acceleration, the G effective will be under root of A square plus G square, and that has been represented over here. Okay. So using this result, G square plus A square, using this result you can very well calculate the value of time period, and I suppose you have just understood the result. So it will be 2 pi under root of L upon under root of G square plus A square. Okay. And suppose now there is a frame and it is moving in downward direction. So now what will occur? So now what will happen? So in this case what happens is the acceleration due to gravity, in this case what happens, the frame isn't accelerating, it is obviously accelerating with G sin theta, but this is because of the component of G only. So the component of G which is acting on the platform, it is also acting on this pendulum as well. Okay. So if the frame is acting in G sin theta, then obviously this also has a component, it also has a value of G, right? So it will also have a component of G sin theta over here, and G cos theta like this. So what will happen? The pseudo force because of this G sin theta, the frame's acceleration, will cancel this existing G sin theta of the pendulum. So overall what I actually mean to say is that along the inclined plane, there won't be any acceleration component affecting the time period of this pendulum. The only acceleration now it will have is the acceleration along the direction, along this direction, and that obviously is g cos theta. So the time period will be varied like this. And this is a pretty confusing thing, so many students face this kind of a difficulty. So if you are facing any difficulty, just memorize this fact that whenever I am actually having a simple pendulum on a trolley which is moving down the incline, then the effective time period now will be 2 pi under root of L upon g cos of theta. Okay, so this is how we actually find the time period of simple pendulum in different cases. Okay, so hi Avi, I am very good. Avi, how are you? How have you been? And are you understanding these concepts? Just tell me in the chat list. Now let's talk a different case wherein now a plus q charge has been provided. So what I was telling you is that the cases of simple harmonic motion can be asked in electrostats as well, and this is a very the very case of it, giving you a glimpse of what scope SHM has in different units. So a direct question from SHM is rare, but the uses of concepts of SHM in various chapters, it's quite evident. So you need to understand these things. Okay. Now if I talk about this case wherein a plus q charge has been given to this bob and an electric field has been imparted, then what will be the case? So obviously since it has a mass, there will be acceleration due to gravity in downward direction, and there will be a QE force in forward direction. Okay, and because of this QE force, this will obviously experience an acceleration equivalent to QE by m. And so the net G effective will obviously be the component, the resultant of these two vectors, and the graph, the time period will turn out to be like this, 2 pi under root of L upon G square plus QE upon m whole square. Okay, so this will be the case when horizontal electric field is applied. Now time period of such a pendulum, when the pendulum has a length equivalent to the radius of Earth. Highly hypothetical, but since it is, so we need to understand this fact as well, that if the length of that simple pendulum is equivalent, very similar or very comparable, it is of few hundred kilometers, which is very rare, but still we need to study it. So if a pendulum is made with its length as in so much kilometers, then the time period is, just memorize the statement, under root of 1 upon G into 1 upon L plus 1 upon Re, where L is obviously the length and Re is the radius of Earth. And what is the value of radius of Earth? So radius of Earth is 6400 kilometers. Okay, it is 6400 kilometers. Okay, okay. Now on varying some, L is changed, length has been changed. Now the formulation which you are seeing over here are actually depicting when the changes are not in that great amount, because the results which you are seeing are found out using error analysis, and they are completely based on the fact that the change should not be very huge. If it is very huge, then these concepts do not arise. These concepts can be very well understood using the concepts of differentiation as well, but you should very well keep in mind that the change, the delta L and the delta G shouldn't be very much, or else this result will not stand, will not hold good. Okay, so if the change is very minor, if the length has been changed, let's say suppose by 3%, 2%, then you can very well use this result. Or if delta G, gravity has been changed by 2, 3, 4%, then also you can use this result. So how the time will change? So delta T by T will obviously be equal to 1 by 2 times delta L by L. So if L length is getting increased, then time will obviously get increased. But on the other hand, if G is getting increased, then time will reduce. And that is this minus sign, so justifying this fact over here. Okay, so in the error analysis portion, we never use a minus sign, but we should very well know that time has an inverse relation with G. So if G is increasing, that means time will have to decrease, and this is the case, and this formulation you can very well use in calculating the results. Okay, so I think we have understood all the basic concepts, all the variations which can be asked in questions in exams in JEE Mains based on simple pendulum, and the reason why I put them is because they are readily very frequently asked. You might see when you will also solve test series of so many organizations of even Extramarks, when it will be live for you people, you can see so many questions of simple pendulum. A simple harmonic motion without a simple pendulum is just incomplete. So there is a very good weightage of simple pendulum, and you should be knowing all the relevant cases which are there in it. Okay. Now let's solve this question. A simple pendulum mass m swings with a maximum angular displacement of 60 degrees. When its angular displacement is 30 degrees, the tension in the string is a conceptual question, but you should know the result, how we are actually finding the whichever is the correct answer. So what it says is that a simple pendulum has a maximum angular axis displacement of 60 degree, but presently it is at 30 degree. So what can you say about the tension in the string? Less than mg cos 30, greater than. So what we need to do? We just need to draw the field body diagram and draw all the forces. So obviously there will be a tension force, there will be an mg, and obviously mg will have a component like this. This is 30, this is 30, so this will be equal to mg cos of 30, and this will be equal to mg sine of 30. Mg sine 30 as usual will provide a torque, a restoring torque. On the other hand, T. So since this bob, this pendulum has a maximum displacement of 60 degree, so either it will be coming from that maximum or the extreme position, or it will be going towards that. In both the cases, it will be having some velocity, some angular velocity, right? It will be having some tangential velocity even. So that means it is following a circular path. And what is the condition for a circular path to be followed? That there should be some axis force towards the center, which should act like a necessary centripetal force over there. So that means T will have two responsibilities. First, it will have to balance mg cos theta and simultaneously provide that necessary centripetal force even. So I think this equation very well justifies the fact that it has to be greater than mg cos theta, and this is our right answer. So now I suppose you just understood this fact, how we just solved this question. It was a very simple one, but a conceptual one. You need to understand these basic concepts, how centripetal force came into action over here, and the case wasn't even related with simple harmonic motion. It's time calculation or whatever it is. But the only fact that you should be having an understanding about centripetal force, how it works and why it is necessary. Whenever a circular motion is occurring, you should be hunting for that centripetal force always. Now let's proceed further and talk about the very famous spring mass systems. So you might encounter questions based on them as well, of spring mass, and that's the reason I have placed them. So a normal spring, if I talk about, there's a spring of constant k, a normal mass m attached to it. When it is displaced, it will oscillate, and the time period of oscillation will be equal to 2 pi under root of m by k. Now based on this expression, you need to memorize this expression. Okay, so whenever the forces are constant, so now I just take the case of this when I've just hanged it from a particular height h, and in the influence of mg also it is acting, then also the time period will remain same whether this simple this spring block system is occurring on let's say suppose inclined plane. Okay, if on an inclined plane it is occurring, I'll just draw the cases. So one of the case can be like this, that it is because of the effect of gravity it is moving, or the other case that this is the case, or the other case will be so in all these cases you can see this is the block obviously m, and the spring constant is k. In all these cases, so obviously the force acting over here will be mg cos theta and will be changed from mg, but the force is constant, So whenever you encounter a force as constant with mass, simple, a spring attached and a simple mass, just avoid any calculations and just remember the fact that time period will be equal to 2 pi under root of m by k. Okay, are you getting the point? So whenever the force is constant, whatever it is, and the arrangement is just like that, only a spring of constant k and a mass of object m has been placed, the configuration should not change. Okay, if the configuration changes, if two masses or two springs have been attached, then we will be discussing the cases of that, but whenever you encounter cases of them, the time period, always remember, it will be equal to 2 pi under root of m by k. And how we derive it? We use the concepts from equilibrium. We justify that at equilibrium mg is equal to kx naught. In this figure only you can just justify it. Then what we'll do, we'll just displace it a bit from its mean position. That's the derivation part basically. So on displacing it, what happens? The amount of force increases. So it becomes kx plus x naught. And how much it increases? So now the elongation is kx plus x naught minus mg. At equilibrium, kx naught was the elongation was x naught. Now elongation has increased, so the net force now will be kx plus x naught minus mg. This will get cancelled by this, so this will be the value of net force. As you can see, the net force is directly proportional coming to x. So from that we can very well decide this will be A equal to minus k by m into x, and on comparing this equation with A is equal to minus omega square x, so this m will come over here, right? This m will come over here, and d square x by dt square is A. So A is coming out to be minus k by mx, and comparing it with A is equal to minus omega square x, what you will be getting the value of omega? Omega will turn out to be under root of k by m, and if omega is under root of k by m, then time period obviously has to be 2 pi under root of m by k. So that's the evaluation, that's the derivation part, but I think I give you a very good trick that whenever the forces are constant and the configuration remains same, a normal spring, a normal mass, then time period irrespective of whatever arrangement you have placed them in will be equal to 2 pi under root of m by k. Okay. Now let's do some alterations, let's do some maneuvering and add some further springs or further blocks or further masses over here, and let's see how the value of time period is changing. So what we have done over here is we had a normal spring with a mass. Now we have attached another spring of constant K2. So now how the result will change? So if you remember the addition of resistors, so this figure and is somewhat depicting like this, right? The resistors one R1 and then one more R2. So the addition over here of resistors was how much? It was a series connection, and they just added it to be R1 plus R2 is equal to R equivalent. So the case of addition of springs is just the converse of this. So the addition now will follow what was the addition or the rule when we used to calculate the parallel connection of resistors. So the K effective of both these, will be related by the relation that 1 upon K effective will be equal to 1 upon K1 plus 1 upon K2. Okay. Just like the case is when two resistors in parallel are getting connected and we need to find the equivalent resistance. So the equivalent spring constant is like this when we talk about a series connection of spring constant. Just analyze it, just remember it using this this analogy, because I also used to do it because we have capacitors, we have resistors, we have now inductors even. These things we will be discussing in class 12, and now we have these very new one as spring constant. We also have conductors in conduction. So many of them are there. Just remember this resistor one and just try and relate it with the resistors one. In capacitor also the same approach occurs. So just try using and relating it with a value, with a thing which you very well know. So the combination of resistors, we are very pro at that, because those things we have already studied in our 10th, 8th and so many previous classes. So very well know what is the value of equivalent resistance when they are in series and when they are in parallel. So try relating with that. So the formulation over here will be somewhat conveying the parallel equivalent resistance in case of resistors. Okay, so the series over here is in sync with the parallel connection of the resistors. Okay, and whatever be the amount of spring constant, you suppose you add K3 as well, then there will be an element of 1 upon K3 as well. And if there are two only, then remember the fact K effective will be equal to K1 K2 upon K1 plus K2. Yeah, true. Just add them up and place them, just alternate numerator को denominator बनाओ. So K effective की value K1 K2 upon K1 plus K2 आ जाएगी. And इस तरीके से याद रखो. So the 2 pi will be equal to M upon K effective. M upon क्या होता है? K effective. यहाँ पे it will be like this. Wait. So the entire formulation will be 2 pi under root of M upon K effective. And what is 1 upon K effective? 1 upon K effective has been replaced by 1 upon K1 plus K2. So this 1 upon K1 plus K2 will not come in the denominator. Instead, this expression is not right. Okay, don't memorize this expression. Instead, it is T is equal to 2 pi under root of M into 1 upon K1 plus 1 upon K2. Okay, okay, this is the correct expression. Mass times 1 upon K1 plus 1 upon K2, because that will be equal to 1 upon K effective. This 1 upon K1 K2 is not in the denominator, it is in multiplication to mass, and this is the correct formulation for time period. I hope you understood this fact, that how time period can be calculated when two springs come into action. Now let's alter it and arrange the fashion similar to that of a parallel connection. So as I told you, as I have stressed in the previous slide, that how series was in sync with the parallel connection of resistors. So over here the parallel connection of these swing constants will be in sync with the series connection of resistors. So this K1 plus K2 will add up just in the fashion how resistors in series got added up. So over here the K effective will instead be K1 plus K2, and I suppose it's very well clear in front of you. And this case is actually the similar case happening over here. So two springs attached in this fashion, this case will actually be very similar and exactly like that only. And how it is, I'll just tell you. So what happens is, suppose you are compressing this block, you are compressing both the springs by an equal amount, right? You are compressing both the blocks by an equal amount, right? So energy stores in them. Yeah, true sir, it's very true. Now what happens is, suppose you are just pushing this block over here towards left. So now what you will say, sir, this is getting compressed but this is getting elongated. But you are not considering the case that the spring behaves whenever it is compressed or it's elongated, the same amount of energy gets stored, that's equivalent to half kx square. So if you just shift this from by a distance of x, it will also have an energy equivalent to 1 by half k1x square, and it will also have an energy equivalent of half k2x square. So this case is obviously similar to that only, and hence the result is also same. So over here also you can just consider this case similar to that only, and the result will turn out to be 2 pi under root of m upon k effective, and k effective is obviously k1 plus k2. Is it clear? Very well. It should be clear to all of you how we got this final result, and you should definitely keep this in mind. Okay. So now let's solve this question. Let's solve this question to understand, have we learnt it properly or not. If you are right, then we have obviously learnt properly. So what is happening over here is, as you can see, there are two parallel connections. So two parallel connections of springs will add up just like k1 plus k2. So it will turn out to be 2k, and 2k and k are in series. So what about series connection? I just told you, जब भी आपको दो स्विंग कांस्टेंट मिले k1 और k2, तो उनका सीरीज कनेक्शन में रिजल्ट क्या रहेगा, k1 k2 upon k1 plus k2. So ये ऊपर आ गया 2k, this is k, so k effective will obviously be equal to k1 k2 upon k1 plus k2, that is 2k into k upon 2k plus k. True? Very true. So this will in turn turn out to be 2k by 3, and this is the value of k effective. So now what will be the value of time? So time will turn out to be 2 pi under root of m upon k effective, and what is k effective? It is 2k by 3, and this is the right answer. This is the right answer, my brothers. This is the right answer. So 3m upon 2k, is there an option? Yes it is, and we are absolutely correct. We got the right answer. Okay. There's no prize money for the right answers over here, but we still got it right. Okay, so I suppose you have just understood the ideation behind how we calculated this result. Now let's move ahead and talk about some physical pendulums as well. So how physical pendulums work. So if there is a rigid body, we obviously understood the cases of simple pendulum, right? And in case of simple pendulum also, I actually told you that how alpha was related with mg into L upon I with a minus sign into theta, right? So this was the case, and I was telling you just replace alpha is equal to minus omega square theta. So this omega will turn out to be under root of mgl upon I, and if omega is turning out to be this, then time period obviously will be 2 pi under root of I upon mgd, where mgd is what? mgd is what? mgd is this distance, the point of application of the force from the axis of rotation. So in that case, in case of simple pendulum, what was this distance d? This was the length of the pendulum. Okay. So using this result, you can very well calculate the value of simple pendulum as well. So just imagine this rigid body. Just imagine this rigid body, and it has been hinged at this point. It has been hinged at, यहाँ पे we have just inserted a nail and it has been hinged. So it definitely has the ability to rotate, right? It definitely has the ability to rotate, and it is not rotate to oscillate. So if it is oscillating, then it surely should have a time period, and if the oscillations are of very small angle, then those oscillations can be termed to be angular simple harmonic motions, and the time period will be equivalent to this, where I is what? I is moment of inertia, it's not L. Okay, I is moment of inertia, and I suppose you all must be knowing about moment of inertia. If not, kindly refer the session of rotational motion 1 and 2 to better understand what moment of inertia is and how we can calculate the moment of inertia about any axis of rotation using those two theorems of parallel axis and perpendicular axis. Okay. So, we just need to calculate the moment of inertia of this entire body about this point, the point about which it has been hinged, and then we can replace it over there, and the final result will be just your maths, which will give you the final answer. Now let us take the case of a rod. So, suppose a rod has been hinged about one of its ends. Okay, it has been hinged about one of its ends. So, how will the time period be of that rod? So, obviously this is mg, the point of application of mg, the center of mass, this length is L by 2. So, the result will be how much? It will be 2 pi under root of I upon mgd, gd, d will be equal to L by 2 in this case. And what is the value of I? What is the value of I for a rod which is hinged about one of its ends? If you know the moment of inertia, it is ml square by 3. Okay, so this 2 will go over there, 3 will come down, and the final result will turn out to be 2 under root of 2L by 3G. Okay, Probin, how are you? And if you are loving this explanation, then yeah, Probin, subscribe the channel, hit the like button, and share these sessions with your friends as well. Any of your friends who might be in need of these sessions, they will definitely thank you a lot. Okay, so now let's take the case of a ring as well. Okay, so a ring of mass m and radius r pivoted at a point O on its periphery. So this is the point where it has been pivoted, and it is obviously in motion about that point. Okay, now it also must be having some angular SHM, obviously, because the oscillations are not, the angular displacement are of a very small value, the theta is very small. So then what will be the value of time? So the time will be obviously equal to, just related by that result only, I upon mgd, and I about this point you need to calculate. So you very well know this is a ring, right? It's a ring. So about the center of mass it is mr square, and about this point you can very well calculate it using parallel axis theorem. So it will be equal to mr square plus mr square, that will be 2mr square. So 2mr square upon mgd, and this is the value over here, mg will be acting. So this distance is obviously equivalent to r. So 2mr square upon mgd, it will turn out to be 2r by g, and this is how we finally calculate the value of time period of any physical pendulum. Okay, so I suppose you got the result. Now they can ask you about a sphere, they can ask you about a disc, and depending upon their positions, wherever they have been hinged about, you can calculate the result. Now let's move ahead and talk about reality. So what is reality? Reality is that whenever you just leave a pendulum, it obviously oscillates for a while, and that it finally stops after some time. So in reality, dissipative forces are in action, and they will obviously slow down a pendulum, and it will damp after some time, and this is what we are going to study now. So what happens is, if there is any dissipative force like viscous force, obviously we are in air, without air we cannot breathe, we are obviously not on moon, right? So on moon it could be possible that the dissipative forces of air would have been very reduced, but still it would have stopped after some time, because there are so many other things also which govern it. Okay, so then what happens, because of the dissipative forces, the amplitude keeps on decreasing. As I told you, the pendulum, it just reduces its amplitude, and after some time it stops, and the amplitude varies like this. It varies like this. The value, as you can see, this is the value of amplitude. It is continuously getting decreased, and these oscillations are known as what? Damped oscillations, because after some time they do damp and the amplitude turns out to be 0. So now what is the result? What is the if you just want the oscillation to commence for long, then there should be some external input of power, external work done, and there comes the concept of forced oscillation. But before that, let's just quantify this damped oscillation, how it is actually being done, and what is the mathematical relation to express it. Okay, so what happens is that you very well know that for a simple harmonic motion, the only force acting should be equal to minus of omega square x, right? Minus of m omega square x, right? It should be equal to minus of m omega square x. But in reality what happens is, along with this there is a dissipative forces also acting in, and because of those dissipative forces we add element of Fv, okay, Fv, and those dissipative forces are obviously related by the speed. So more speed you have, the more is the viscous force acting on you. So if you remember the lecture of fluid dynamics, then that Stokes law, what it said clearly that the viscous force acting on a spherical body is equal to minus 6 pi eta a into v, where a is radius and v is obviously its velocity. And this is the only fact that due to air drag forces, whenever a person is skydiving, after some time his velocity becomes constant. So it is not the case that he just moves downward with an increasing amount of velocity because of the effect of gravity. Obviously air comes into action, and air is acting a force in upward direction opposite to its motion in downward direction, and the magnitude of that force is directly related with the velocity which he has. So there comes a point when his velocity is so much that the viscous forces are balancing mg, and there after that he moves downward with a constant velocity, and that is the fact. So this viscous force which you are viewing is directly proportional to v. Okay, and this expression, so I can just replace this f by m into d square x by dt square. Okay, over here also m will arise over here as minus m omega square x, and this fv can be replaced by any constant times velocity, and velocity can be written as dx by dt, and this entire expression has been summed up over here. This b into dx by dt is what written over here. Okay, so this is the expression whenever damped oscillation is occurring. Okay, this is the expression whenever a damped oscillation is occurring, that m into d square x by dt square plus b times dx by dt plus kx is equal to 0. And using differential equations, which is obviously a topic of mathematics, so we do not have to get into that, we need to understand the physics behind it. So ask Divyapal sir, he will be very readily telling you that how you can derive equation using this expression. So on using differential equations, the concept over here, we can very well say that x now will be equivalent to a into sine of omega dash t plus phi, where a is now a parameter of time. Okay, so a is, unlike the cases previously where a was constant, now a is also a variable and depending upon time, and as you can see this minus sign over here, so with time the value of amplitude will decrease. Okay, and this is the reason behind damping of an oscillator after some time. Okay, so this is what damped oscillation is all about. But if you people want that the damping should not occur and our oscillator should keep on move, then you will have to go for that forced oscillation. Okay, just remember the case wherein this is a sport, right, something of this type. A person sits over here, एक झूला होता है ये, it's a playing sport. So in this you just push him up, he moves over there and he returns back. So what is the next time you push him up? The next time when you push him up is obviously the time when he is again at this position and moving in forward direction. That's the best time, because at that time if you push it up, then obviously its amplitude will increase from its initial value, and when it is coming in backward direction we never push it up because that will actually reduce its amplitude. So here comes this concept of resonance even. So based on what force oscillation is, resonance also comes into action, that what should be the driving frequency, what should be the frequency of the forced oscillation which we are doing such that we achieve the state of resonance, that is maximum amplitude, and we will be studying that also. So yeah, just first let us just cover this up. So angular frequency of a damped oscillation will be equal to omega naught square minus b by 2m. Okay, so this will be the frequency, it will obviously remain constant, and omega net was obviously under root of k by m. Okay, perfect. Now let's discuss about forced oscillation. So what happens in a forced oscillation? If you want the oscillation to commence, to go on, then you will have to apply a force. So dissipative forces are actually providing a negative effect on your already ongoing oscillation. So and they are obviously dependent upon velocity. Okay, so as velocity is increasing, their value is also increasing, and instead we got a relation of x wherein amplitude was turning out to be a function of time. So to avoid that, we need to apply a force, and which instead should be a function of time. So the force applied should be equivalent to f naught cos of omega d into t. Now what is omega d? It is known as the driving frequency, the force which you are applying, the frequency of that. So suppose you are applying a force after 1 second. After 1 second you are again and again applying a force on an object. So the driving frequency will obviously, you can very well calculate it to be 2 by f. Okay. So if your frequency is 1 hertz, that is one time you are applying a force in 1 second, so then your driving frequency will be 2 pi into f, that is 2 pi. Okay. So this is the value of driving frequency. Okay, perfect sir. Now with the effect of this driving frequency, if you just remember the expression, so this was the force, and till now we have just considered these results. Okay, this was the ideal situation when your force was equivalent to minus kx. Then we drove into reality and this minus bvt came into action. Okay, and because of that, damping was occurring. Now we are forcing it up such that the oscillation should commence, it should not stop, and for that result we are applying a force which is instead a function of time. Okay, so because of this force, now the acceleration will be just divide this m, and again consult Devpal sir for that how d square x upon dt square, and over here x, then v will be replaced by dx by dt, and over here also you will instead get a function of x, and that function will now be equivalent to this. Okay. So now the amplitude will be equal to f naught upon m square omega square minus omega d square plus omega square d into b square. B was obviously the constant of the viscous forces, d omega with a subscript d is the driving frequency, and omega naught is your individual frequency. Okay. So this result will give you the value of amplitude now. This will be the expression of amplitude, and how we got that, you will have to get into deep mathematical troubles to arrive over there. So you will have to use differential equations. I don't suppose you can get the result also in a very quick span of time, but you should just get an idea about what actually forced oscillation is and the concept of resonance, what it turns out to be. So now just look over here towards this expression of amplitude. So what can you say about the expression of amplitude? What can you say about the expression of amplitude? If you want the amplitude to be very large, if you want the amplitude to be perfect, to be maximum, not very large, to be maximum, with a driving frequency you are applying a force which is instead a function of time, and you want that the resonance should occur. And what is the case of resonance? That our amplitude should be maximum. So for this to be maximum, your f naught is obviously maximum. Can you just alter some things over here? So the numerator should be least for a to be maximum. How it can be least? Can you just make this omega d equal to 0? No, you cannot. If you just remove this driving frequency, that means you are not applying a force. That means what happens is, that means no forced oscillation is occurring, then that means the case again turns out to be a damped simple oscillation, and again you just are avoiding the damping. So you cannot make this driving frequency 0, right? What you can do is, this term whose square is getting added to this term, I can make this term to be 0. I can make this term to be 0. And how I am going to do that? Will be equating this omega and this driving frequency. So the entire case of resonance now is that when the driving frequency is very close to the natural frequency, and this is the case which I wanted you all to stress upon. So when the driving frequency is very close, obviously you can try your best to make it as exact as possible, but in a normal sense, since we are discussing real cases, so in reality just try and make your driving frequency very close to natural frequency, and in doing so what you will do is you will just reduce this value, and on reducing this value the entire numerator will decrease, and instead your amplitude will be a maximum value. So your maximum value of amplitude will be f naught upon omega d into b. Okay, and this is the case of resonance when amplitude is maximum. Okay. So even this concept of resonance is very relative. So if you people are understanding what I am saying, then we both are in resonance, right? Because the timing of mine giving you the facts and your brain or your mind understanding those facts, if we are in sync, then we are in resonance. Okay. So resonance is very relative with the real world as well. So wherever you are having a very tuning, you have very good friends over there, and you have a very nice relationship with them, that means you are actually in resonance with them, because the frequency with which your mind works is actually in sync with there as well. So with this very beautiful topic, we'll have to close the session, and this will be the end of this lecture. I suppose you just enjoyed this session, and you understand a lot about what simple harmonic motion is and what all important topics, concepts we can actually encounter from simple harmonic motion. But this is not all. Obviously, I am again and again stressing, and I'll be keep on doing that. Practicing questions is a very eminent responsibility for every student for whichever exam he is trying for. Okay, whether it be JEE, NEET, or when you just graduate from your college, then also there are so many exams which you can aim for. Then also, without practicing questions and giving tests, you seriously cannot ever expect that you will clear an exam. And this is a very harsh reality, but it is, because there is very heavy competition over here in India, and to ace yourself or to ace a particular rank, to prove someone, you obviously have to put in a lot amount of effort from your side, and a lot amount of effort should also be in a proper fashion. It should not be very random, and that is the reason I am telling you, download the app, because what you will be getting is, you will getting a very segmented kind of questions. See, suppose you are having trouble of solving questions of thermodynamics, but not of KTG, not of heat, but you are facing trouble solving questions of conduction. So you should get a platform wherein you can solve those very eminent, very required questions of topics. Questions are divided among topics, among subtopics, and this is the best platform you can go for. You can just download it and apply some filters, and you can get the questions, and the questions have also been marked with a difficulty parameter, or whether they are easy, whether they are mediocre, whether they are difficult, and based on that you can also get to know that are we seriously studying, or what is your level of preparation. And also, don't stop over there, try tests. Yeah, without giving test, you seriously cannot ever expect that you will perform a brilliant you'll have a brilliant examination on that final day. So you have to give tests, you will have to sit on those 3 hours, you will have to create a climate of those 3 hours at your home and give as many tests as possible, because giving a test actually increases your confidence to a very next level, and this is actually very, very important if you are actually preparing for an exam like JEE. Okay. So these will be my personal recommendations for you. If you want to better your existing preparation, do download the app, practice questions, give tests, and study the analysis report, because that is also very important. सो हम नेक्स्ट सेशन में मिलते हैं, जो कि कल ही है. सो डोंट वरी, हम कल फिर मिलेंगे, कल सारी बातें करेंगे और एक नया चैप्टर वेव्स के बारे में डिस्कशन करेंगे. देयर विल बी अ वेरी ग्रेट डिस्कशन अबाउट वेव्स, ऑल दोज टॉपिक्स, ऑल दोज इंपॉर्टेंट एलिमेंट्स. जिन लोगों को सेशन अच्छा लगा, प्लीज़ लाइक करो, सब्सक्राइब करो, कमेंट भी करो. कमेंट से आई गेट टू नो यार कि व्हाट ऑल मॉडिफिकेशंस, व्हाट ऑल इंप्रूवमेंट्स आई नीड टू डू. इवन आई हैव टू मेक सम इंप्रूवमेंट्स, राइट. आई कंसिडर द फैक्ट, जो भी आप बोलोगे, इफ दे आर लेजिटिमेट, वी विल डेफिनेटली इंप्लीमेंट देम, बिकॉज दिस सेशंस आर ओनली फॉर यू गाइज, जिससे कि आप लोग अपनी ऑनगोइंग प्रिपरेशन को और ज़्यादा एनर्जी के साथ और ज़्यादा अमेजिंग तरीके से कंप्लीट कर पाओ. सो हम फिर मिलते हैं कल 5 PM सेम टाइम. ओके, टिल देन, बाय बाय, हैप्पी लर्निंग, या स्टे सेफ, बाय बाय.